I'm with Fisheries and Oceans Canada at the Sea Lamprey Control Centre in the Soo. Jessica Barber and I put together some slides to explain a transition that we're going through now with the adult sea lamprey population assessment. This transition is kind of the result of several years of research and just kind of internal review within the program, within the task forces that we have in the sea lamprey family, and then the Sea Lamprey Control Board as well. So, as you've heard today, there's a few different metrics that we use to assess the sea lamprey control program, and one of those is the adult sea lamprey abundance. So that's what we're focusing on here. And just as a reminder, we switched and we adopted this new adult index method in 2015, and so this is an index of relative abundance, and it replaced the spawner model or kind of a regression model that attempted to estimate the absolute abundance. So now we're just looking at an index of abundance. And this adult index uses abundance estimates from trapping, trap catches of adult sea lamprey in index streams, and these index streams were chosen. The ones that were chosen had the largest runs. They're kind of the drivers of the trend of those time series that you see. They had over 90% of the annual trap catch compared to what we, the number of streams we used to trap, and a history of consistent mark recapture estimates, and good geographic coverage around the lakes. So these are the index streams that we have. There are 5 to 7 per lake. 5 or 6 or 7, they're a set number per lake. And we get mark recapture population estimates. And then the index value for each lake for each year is simply the sum of those stream estimates. The title of our presentation is Transition, so it kind of implies that there's a change going on, and that change is related to these mark recapture estimates and the way we derive those. So the change that we're making is changing the mark recapture estimator for in-stream population estimates. We're switching from, you may have heard of this modified Schaefer method that we've used for quite a few years. We're switching to what we're calling the pooled Peterson. Don't want to go into the weeds too much, but the modified Schaefer method is a stratified approach. It's stratified by time, so there's several different, up to 10 or more weeks. The weeks are the strata, and each strata has a different marking scheme, different fin clip on the lamprey. So we're moving from, and then that kind of each strata, there's a strata with the week of marking and the week of recapture. So we have a recovery matrix, and we come up basically with a population estimate for each week and then add those up. So it's fairly complex. We're moving to this pooled Peterson, which is much simpler. It just relies on 3 numbers basically: the number caught for the entire year, number released, and the number recaptured. So something that most people are familiar with, I'm sure. And the reason we're making the change is not just because it's simpler, but because it actually performs better in terms of accuracy and precision. This is based on some work out of the McLaughlin lab at University of Guelph. They did some work in the last couple of years, and it kind of shows that the pooled Peterson is equivalent or better than the Schaefer and even other methods when the sample size is large. So it's about the same. But the important part is that it's more accurate than the Schaefer method when the sample size is small. I'm not gonna talk about this diagram, but I'll just move on. That's just from a paper from Rob McLaughlin. This is also based on some work that Rob McLaughlin did with a grad student, showing the percent bias. So how far we are from the truth, the true population estimate. And so these mark recapture population estimates every one of them has bias. We're trying to minimize that bias. So when you have a lower number of recaptures, it's a little more variable with the Peterson estimate, but with the Schaefer it really falls apart and becomes strongly negatively biased, and so that's kind of the reason that we're moving away from that. So just kind of in summary, using the pooled Peterson makes sense. Statistically, it's simpler and more intuitive, equivalent to the Schaefer with large sample size, and actually more accurate with small sample size. And it's also nice operationally. It makes sense because it's going to be a lot simpler for field operations and catching those errors with the week of marking, week of recapture things, data analysis and management, just easier for everyone to understand. All of our partner groups and even the public. So you're probably wondering what the implications might be for switching to the pooled Peterson and going back in time and recalculating all of those. So making this change will likely affect stream estimates and lake index values and lake index targets as well, and possibly when the years that when targets were met. Changing to the pooled Peterson, though, will not affect which index streams we use, the interpretation of the adult index, any funding or wounding rates. That'll all stay the same. So this is the timeline we're looking at. We've made the recommendation to the Sea Lamprey Control Board, and it's been approved to make this transition. We're just finishing, we're not quite done creating the new time series and targets, presenting it to this is the time we're at now, kind of presenting the new index values and targets. And then we just started trapping this week in some of the lower lakes streams, so just continuing with status quo for now. When you see results in September 2018, those will be based on pooled Peterson. So this is probably what you're thinking. So I'm going to show you the draft index time series using the Peterson estimates, but these are draft. They're not finalized yet. They will change, but we expect the changes will be pretty minor. So the point of me showing them to you is I'll show you the time series based on Schaefer and on Peterson, just to give you an idea of the scale of what the change will look like. So I'll show you one of these graphs for each lake, starting with Lake Superior. I would suggest that you look at the y-axis, the scale, just to see kind of how much higher the Peterson estimates are. In most cases, the Peterson estimates are higher. You can check out the horizontal dash line, which is the target, to see how much higher that is. And then just kind of, I would suggest looking at some of these points close to the line to see if, when we said we were at targets before, if we're still at targets. So that's Lake Superior. You can also kind of look at to see if the trends are similar. Lake Michigan, pretty similar trend with a couple of peaks that are slightly different. Lake Huron, very similar trend. And then since we're at the lower lakes meetings, this is Lake Erie. A few differences here. And then Lake Ontario, which is very similar. So that's basically a quick summary of the change that we're in the process of making. And I guess with that, I can take any questions.